Hey guys, tonight, we're drifting all the way out to the furthest planet in our solar system, good old Neptune. You're bundled up in nothing but curiosity and the gentle hum of a space heater that doesn't exist. Out here, 4.5 billion kilometers from Earth, the stars feel slower, more respectful somehow. You float in darkness so deep it wraps around your ankles, like warm blankets, except it's a chilly, 214°C, and the only blankets are clouds of frozen methane. You're staring at a giant blue orb. Neptune doesn't twinkle or shimmer like the movies promised. It just hangs there the color of glacier mint and lost postcards. The silence is absolute, broken only by your own steady breathing, which is fake, of course. You're not really breathing in space unless you've got a very cozy helmet on, and even then, you probably won't survive this. But don't worry, none of us do. That's not what tonight is about. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Also, drop your location and local time in the comments. I love seeing where you're tuning in from, whether it's midnight in Melbourne or 3 a.m. in Ohio. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Neptune is lonely in a way only gas giants can be. It's not the cool, aloof kind of lonely like Saturn, always flaunting its rings. And it's not the brooding, edgy kind like Pluto sulking in its dwarf status. Neptune's more like the friend who didn't show up to the group chat but still likes your post from 6 days ago. It spins slowly, sure, but that slow spin isn't what you expect. As you approach Neptune, you notice it doesn't welcome you with roaring storms or flares of light. No lightning tantrums like Jupiter, no icy grandeur like Uranus. It just turns, steady, mildly indifferent. You tilt your head in confusion. How can this quiet blue marble host the most ferocious winds in the entire solar system? But we'll get to that. You glide closer, brushing against the uppermost haze of Neptune's atmosphere. The color is what grabs you, this rich, impossible blue. It's not the baby blue of Earth from orbit, or the pale teal of Uranus. Neptune's blue has depth. It's like someone painted the sky using crushed sapphires and melancholy. Scientists think methane in the atmosphere absorbs red light and reflects blue, but that's only part of the story. They still debate why Neptune is this bluer than Uranus, despite their similar makeup. Could it be unknown particles, optical illusions, Photoshop? You drift downward, layer by layer, through hydrogen and helium, and of course methane. It's like falling through a snow globe, where the snow has anxiety and doesn't want to be noticed. The atmosphere thickens slowly, turning into a pressurized soup of icy gases. Somewhere in there, the gas transitions into fluid Neptune's elusive surface, which is kind of like calling whipped cream a floor. And below that, pressure that would squish a cruise ship into modern art. A mantle of water, ammonia, and methane compressed into a weird, slushy state that behaves more like angry jelly than actual ice. You think of it like a smoothie if smoothies were 10,000 kilometers thick and could end your entire existence with one frown. A gust of wind brushes past your visor. You pause. That's weird. There's no reason to expect motion out here. The sun's too far away to give Neptune much energy, only about 1/900th of what Earth gets. So where does this energy come from? You pass a floating pocket of turbulence, lazily rotating like a dream that forgot its plot. The winds haven't gotten rowdy yet. That comes later. For now, everything feels slow, suspended, like Neptune's pressing snooze on every law of physics. You look down and try to spot something familiar. A tree, a rock, a single obedient patch of land. But Neptune has no solid surface. It's all gas and fluid and mystery. You could fall forever and never reach anything you can stand on. That fact alone makes your bones feel less important. There's a strange comfort here in the structurelessness. You're not weighed down by direction. Up, down, they don't apply. All that matters is drifting, listening, feeling the subtle shifts in temperature and density as Neptune gently sculpts the space around you. Somewhere off to your left, a plume of methane-rich mist curls upward. It looks like steam from a giant cup of tea. You half expect a sleepy alien librarian to appear and offer you a biscuit. Instead, you get silence and the swirling movement of a gas giant that's just starting to wake up. Scientists think Neptune emits more internal heat than it gets from the sun, more than any other planet in the outer solar system. Maybe that's the secret to its active atmosphere. Maybe not. Astrophysicists still debate whether Neptune's warmth is from leftover planetary formation or something stranger, like radioactive decay in its core, or a slow gravitational slosh fest. You pass a pocket of calmer sky where the winds barely register. Here in this quiet patch, you can imagine ancient astronomers staring up at the night sky, noticing a slow-moving star that didn't follow the rules. That's how Neptune was discovered, not by telescope, but by math. Calculations predicted its presence before anyone ever saw it. You float in that history for a moment, humans looking up, guessing correctly. It's one of those rare moments where math actually delivered a planet. Neptune was confirmed in 1846, long before anyone could dream of visiting it, let alone getting blasted with hypothetical methane storms. You pass a faint shadow, the first hint of something, brewing deeper inside the planet. It slips past you like a shy creature, unsure if it wants to be seen. Your limbs feel loose now, relaxed. The blue quiet seeps into your muscles, your breath, your spine. You're not in any rush. Neptune certainly isn't. It spins at its own pace, waiting for no one answering, only to physics and whimsy. You're here now, and Neptune has nothing to prove. The blue haze curls tighter around you as you sink deeper into Neptune's upper atmosphere. The stillness you felt earlier starts to fray at the edges. There's a shift, almost imperceptible at first. A ripple. A twitch in the clouds. Something beneath all that calm is stretching its limbs. Then you feel it. Wind. Not a breeze. Not a gust. Wind. The kind that would tear umbrellas in half and throw your groceries into another county. Except here, it's quiet. There's no sound, because there's no air in the traditional sense. Nothing for the wind to crash against, no leaves to rustle, no flags to flap. Just movement. Just atmosphere, hurling itself around the planet at over 200 miles per hour. Yes, you read that right. Neptune's winds can reach up to 2100 kilometers per hour, faster than the speed of sound on Earth. You're surrounded by it now. A silky high-speed conveyor belt of hydrogen and helium and whatever ghosts live in Neptune's sky. It doesn't feel like danger. It feels like purpose. Like the planet is trying to shake off a dream it can't remember. Astrophysicists still argue about how Neptune manages this. With so little solar energy, and a rotation that's not particularly fast, it shouldn't have the momentum for this kind of atmospheric drama. It's like finding a snail that somehow broke the land speed record. Explanations range from leftover heat from formation, to deep atmospheric convection, to it just really wants to. You drift sideways now, pulled by the jet stream like a leaf in a whirlpool. No resistance, no drag. Just hypnotic speed, and the occasional swirl of methane clouds that look like slow-motion fireworks. The colors shift subtly blue to cobalt, to a sort of bruised lavender, and every now and then you pass a streak of white like whipped cream, flung across a painting. These are Neptune's high-altitude clouds. They ride atop the chaos like bored passengers, barely holding form, as they circle the planet in record time. Some of them are made of frozen methane ice. Imagine snow, but sharper. Reflective, suspended in a constant sprint around the world. Below, the wind divides into lanes, like traffic, but with fewer honks. Neptune has bands like Jupiter and Saturn, but they're less obvious, more secretive. You start to see the outlines now. Currents flowing in opposite directions, stacking and colliding, and whispering insults at one another. One band spins westward, another eastward just below it. The resulting friction causes storms. Not the explosive kind, but the simmering type. The kind that hold grudges. And yet, Neptune's core doesn't seem to care. It spins slowly, almost reluctantly. There's a mismatch here, like the planet's skin is doing Zumba, while the interior is still sipping tea. It's an unsolved riddle. If the core is lazy, why are the winds manic? Some think it's due to the planet's strange internal heat distribution. Others point to the lack of a solid surface, which means winds don't hit friction and just keep going. Like a fidget spinner in zero gravity, it'll whirl until you forcibly stop it. Neptune might also have a deep turbulent layer of fluid that helps drive surface winds. Imagine hot, compressed ammonia and water sloshing around like a cosmic smoothie, creating invisible whirlpools that bubble up into faster, fiercer winds above. You consider this for a moment, then wonder if you'll ever drink a smoothie again without imagining interplanetary jet streams. Below you now, a dark smudge rotates ominously. It's not a shadow, it's a storm, a vortex, one of Neptune's many temporary tempests. They form and vanish like dreams. Some last for years, others for mere months. Unlike Jupiter's great red spot, which has held a grudge for centuries, Neptune's storms are more like performance art here, for a while, then gone, leaving no forwarding address. You get closer. The storm's edge curls like the lip of a wave. The core is darker, denser, like a bruise on the sky. You can't help but feel drawn in. The wind wraps around the storm, in a spiral, pulling you with it, but gently, like a dancer offering a hand. You spin once, twice. The view blurs, then sharpens. You're now part of the motion, not just an observer. The speed is surreal, and yet you feel weightless, anchored by nothing, carried by everything. Somewhere behind you, Neptune's south pole rotates faster than the equator. That's another mystery. The poles seem to defy the usual rules of planetary spin. Earth and Mars. Predictable. Neptune, more of a suggestion than a system. Scientists still debate why the polar regions of gas giants sometimes exhibit different rotational behaviors. Differential rotation, they call it, which is a fancy way of saying even the planet doesn't know what time it is. You try to orient yourself, point toward something stationary. But Neptune has no mountains, no trees, no Wi-Fi towers. Just motion. Layers of motion. You're on a slow carnival ride, powered by invisible forces and really old sunlight. Suddenly you pass through a pocket of calm. A space between gusts. It's like walking through a revolving door and landing in a still room. Here you catch your breath. You look up. The atmosphere stretches infinitely layer upon layer of delicate color and frost. Neptune's upper clouds shimmer faintly. You swear you see the stars behind them twinkle, but that's probably just your imagination doing a little cartwheel. In this quiet, you feel the scale of it. Neptune is 17 times the mass of Earth. It could swallow our planet whole and still have room for leftovers. And yet, it feels intimate, like it's humming just for you. The winds resume, a soft nudge at first, then back to that smooth, endless push. You ride it. You let go. You float forward. You're not trying to get anywhere. There's no destination. Just atmosphere and questions, speed and silence, the joy of motion without pressure, the wild idea that something can be fast and still feel slow. You understand now. Neptune isn't showing off. It's just being itself a planet wrapped in paradox. Still core furious skies. Blue, calm, unexplainable storms. A silent scream across the coldest edge of our solar system. You're not here to solve it. You're just here to listen. You keep drifting sideways, letting the atmosphere cradle you like a very disinterested cloud hammock. The winds are still raging at their breakneck, not quite sound barrier pace, and yet somehow the planet underneath it all is dragging its metaphorical feet. You think about that for a moment, about the mismatch. Because here's the twist that makes astrophysicists tilt their heads and rub their temples. Neptune's atmosphere is fast, absurdly comically fast, but its deep interior rotation seems slow, by comparison. That's like finding out a carousel is spinning at full speed while the motor inside is barely humming. You can almost hear the exasperated sighs from physics departments around the world. They've tried measuring Neptune's rotation using radio emissions, the way they've done with Jupiter and Saturn. Radio waves don't lie, right? Well, except when the magnetosphere is all weird, which spoiler Neptune's is. So estimates vary, and it turns out that figuring out how fast a planet is spinning when it doesn't have a surface is in a word annoying. You hover at a level somewhere between the upper clouds and the theoretical mantle, which is not a real mantle like Earth's, but more of a conceptual smoothie of ices. You try not to think about what it would taste like, probably like regret and hydrogen. Still, the contradiction lingers. Why would a planet whose center rotates at a sleepy 16 to 17 Earth hours per full turn whip its atmosphere into literal frenzy? One theory, the winds are powered more by internal heat than by planetary spin. But we already said Neptune doesn't have that much heat to go around, at least not enough to explain these speeds. Maybe the atmosphere just isn't getting the memo from the core. Maybe the layers are more independent than we imagined, operating like separate departments in a company that doesn't have inter-office email. You let that image settle, a bureaucratic Neptune, where the atmosphere is like the overcaffeinated intern, and the core is the manager who's always out to lunch. But it's more than just a cosmic workplace comedy. This divide between interior spin and atmospheric motion suggests deeper complexity. Something's churning below, maybe a shearing layer where the winds meet denser materials and bounce off building momentum in ways we still don't quite get. You spiral downward, brushing past faint eddies in the air, tiny high-speed whirlpools, barely visible unless you squint. They appear, twist lazily, and dissolve, like the planet is having thoughts and forgetting them mid-sentence. Some scientists speculate that there's an angular momentum handoff happening, Neptune's interior shifting its rotation energy outward into the atmosphere, kind of like a spinning figure skater throwing their jacket into the wind and watching it sail ahead. But it's just a theory. The planet doesn't explain itself. It just spins fast here, slow there, like a record that skips in all the right places. You find yourself wondering how deep this difference goes. Do the winds penetrate all the way to the core, or do they skim the top like a thin skin on thick soup? The answer is, once again, we don't know, which is starting to feel like Neptune's whole personality. And honestly, that's comforting. Not everything has to be solved. You're lying in the lap of a giant question mark, and the lack of resolution feels like a warm blanket. or at least a heavily insulated jumpsuit lined with existential ambiguity. You check in with your body still floating, still intact, still bundled in the fiction of breathable air and protective layers. Down below, where the pressure could crush a submarine like a soda, can you spot the start of what might be Neptune's transition zone? Here, the gas isn't quite gas. It's supercritical fluid, no longer following the rules of solids, liquids, or gases. It's the party where physics gave up on definitions and let everything mingle. A soupy mix of water, methane, ammonia, and hydrogen, behaving more like lava with opinions. As you hover above it, you can almost feel the drag of deeper currents. Not wind, but something heavier, slower. The motion here is a quiet grind. No dramatic whirls, no frantic eddies. Just a patient, eternal churn, like the gears of a grandfather clock. Too old to remember time, but too stubborn to stop ticking. The rotation of Neptune's deeper layers might be entirely separate from its atmosphere. Two clocks on the same wall, each with a different hour. Scientists try to model this, using equations that involve zonal flows and differential rotation. But let's be honest, nobody has solved it. We just watch the winds and shrug politely. You think again of the Voyager 2 flyby in 1989, how it got. Just a few hours with Neptune snapped some blurry pictures, waved at Triton, then left. That one brief encounter is still our best data on this massive mystery. 36 years of guesswork since. And yet, you feel strangely connected. As if Neptune prefers it this way. It doesn't want to be known entirely. It wants you to float, speculate, and then drift on. Another current catches you, pulling you into a gentle loop. You spin once slowly and get one more panoramic view of Neptune's vast blue dome. There are no markings here, no familiar land masses, no hints of origin, just clouds motion, and the knowledge that somewhere below you the planet turns differently than it seems. The core pulses with its own rhythm, and the winds scream above indifferent. You're caught between them, listener to two separate conversations spoken in alien dialects. Somewhere in that in-between space, Neptune spins, barely. And yet the sky runs like it's late for something. You descend further into Neptune's atmosphere, deeper into the ice giant's secretive layers, and the light shifts again. The rich blue around you begins to glow with a subtle intensity, something between a soft lantern flicker and the way water looks when sunlight filters through a swimming pool. But this isn't sunlight. Not really. The sun from way out here is just a brighter than average star. What you're seeing now comes from Neptune itself, scattered light bouncing around methane molecules, like gossip in a small town. You pause, floating just above a luminous haze. There it is again, that strange glow. Not radiant like fire, not reflective like polished metal. It's diffuse. Dreamlike. You reach out a hand, not because you expect to touch anything, but because sometimes you just want to see your own silhouette dancing in alien light. And then it hits you, methane. That's what gives Neptune its signature hue. Tiny methane molecules in the upper atmosphere absorb red wavelengths and reflect the blues back out. That's the textbook version anyway. But the thing is, Uranus has about the same amount of methane and it's not nearly as vividly blue. So what gives? Scientists have tried to model this, tweaking factors like cloud composition, haze particles, maybe even photochemical reactions we don't fully understand. Some think Neptune might have additional unknown aerosols, tiny suspended particles, that affect how light is absorbed and reflected. Others think it's something deeper in the atmosphere, a sort of optical quirk that boosts the blue more than it has any business doing. In other words, the planet is playing coy. It tells you just enough about its chemistry to keep you interested, then changes the subject whenever you dig too deep. You drift sideways again, following a stream of lighter methane clouds. They shimmer in layers, some nearly white, others a dim glowing blue that feels like looking into a forgotten aquarium at night. You half expect a sleepy spacefish to glide past wearing a monocle. Somewhere far below, it's cold enough for methane to condense into crystals. Not snowflakes exactly, but flakes of frozen gas that fall softly into thicker depths, a sort of methane drizzle. You picture it settling like confetti at the world's most introverted parade. Neptune's temperatures hover around 214 degrees at the top, but go deeper and things warm up. Not by much, but enough. It's that contrast frigid surface, slowly heating core that creates the gradients needed for weather. That's how Neptune's storms start. Heat rises, cold sinks, except not always. Because Neptune, like a lot of gas giants, doesn't behave the way you'd expect. Some thermal models suggest that hotter materials can actually sink in certain parts of its fluid layers. That breaks a fundamental Earth-based rule. Hot things rise, cold things sink, and your coffee stays in the mug. But on Neptune, gravity, density, and pressure have their own private meeting and decide to do things differently. You let the absurdity wash over you like a calming fog. Planets don't care about your expectations. They care about mass and motion and whatever weird game of interstellar chemistry they're playing this week. The methane thickens as you drift into a cloud bank. Everything turns hazy, like walking through a gas station freezer, with all the lights dimmed. Your vision narrows, shadows twist. You feel like you're floating through a bowl of blue cotton candy. If cotton candy could punch your lungs with pressure. Even here, the glow continues. You start to notice it's not uniform. It shifts and shimmers depending on where you look. It's as if Neptune is lit from within, not brightly, but just enough to create the illusion of motion, even when things seem still. It makes you think again about how little we understand this world. Methane's behavior at these temperatures and pressures is still a bit of a guessing game. We've recreated some conditions in labs, sure, but not all. Not at this scale. Not with Neptune's unique mix of hydrogen and helium swirling through it like a cosmic cocktail. You feel a distant rumble. Not a sound exactly, but a vibration, a shift in pressure that suggests movement beneath you. The winds. They're still at it, even in this thick haze. You're in their path now, but they don't feel violent. They're fast, yes, but they're smooth, practiced. Like a river that's been flowing for millions of years and knows every curve of its banks. You let yourself be carried again, trusting the wind, trusting Neptune. And as you move, you look back at that glow. That impossible deep blue. It's not just color. It's mood. It's Neptune's personality wrapped in wavelength. Mysterious, calm on the outside, hiding chaos within. You glance upward toward where you came from. The stars are gone now, swallowed by clouds. You're in it, deep in Neptune's atmosphere where light bends, winds rule, and methane paints the sky. And still, somewhere beyond these clouds, scientists argue. Is the color purely from methane, or something more? An unknown compound? A structural anomaly in the atmospheric layers? The debates continue because Neptune won't tell. You smile, because mystery out here is the most comforting thing of all. You keep descending slowly now like a leaf, unsure whether it wants to fall or just hover forever. The winds that once raced around you begin to thin out, not because they're weaker, but because the air here is heavier, thicker with pressure and promise. Down here, Neptune starts to lose its softness. It's no longer the pastel swirl you first admired. The deeper you go, the less defined everything becomes. The lines blur, the clouds compress, and you're left with the distinct impression that this planet never wanted you to visit this far down. Still you're curious, and Neptune in its own aloof way allows it for now. There's no surface to greet you, no Grand Canyon or icy crust or rocky plateau. Neptune doesn't do solid. It does layers, fluidity, viscosity. As you approach what would traditionally be called the surface, you realize you're entering a transitional zone. Above you gas, below you a pressurized ocean of exotic materials that doesn't know whether it's liquid or soup or plasma's weird cousin. This is the mantle, though calling it that makes it sound like something you could put a flower vase on. You cannot. This mantle is composed mainly of water, ammonia, and methane squeezed into forms that would make Earth's oceans cry in confusion. Under the crushing weight of Neptune's gravity, these molecules become supercritical fluids, not solid, not liquid, not gas, just intense. You imagine what it might feel like to touch it. You don't. But if you could, probably like dunking your hand into a pot of boiling jelly that was emotionally distant. This fluid layer stretches tens of thousands of kilometers deep, and yet it's entirely invisible. No horizon, no boundary, no welcome to the mantle sign. Just gradual density and the soft hiss of temperature change. You try to picture what lives here. Spoiler, probably nothing. But your brain determined to make the unrelatable relatable draws comparisons. It imagines deep sea creatures curling phosphorescent tendrils. It hears whale song that isn't really there. It invents life because that's what humans do in darkness. Astrophysicists have their own visions. Some think this region contains diamond rain. Carbon under these pressures could compress into crystalline structures and fall like shimmering snowflakes, except much, much heavier and harder to gift wrap. We'll get to the diamonds later. For now, you're just admiring how alien this all is. You've passed through layers of gas that behave like silk scarves, and now hover above a sea of physics gone rogue. Every sense is dampened. Time feels thick. You feel like you've entered the pages of a story you're not qualified to read. There's motion down here, but it's slower, less frantic. The winds have tired out. What's left is convection, heat rising, cold sinking. Except, again, Neptune doesn't always play by those rules. There are models suggesting that heat gets trapped and doesn't rise like it should. Other models hint at ice crystals forming strange lattices that resist flow, and some theories suggest whole chunks of Neptune's deep interior might rotate at different speeds, like a cosmic layer cake in a centrifuge. You hover over a subtle shimmer, a sign of shifting temperature. There's no light source, but the pressure alone causes glow. You can almost hear it, the hum of molecules, excited just enough to dance, but too tired to shine. There's a mythological vibe here. Neptune, the Roman god of the sea, would approve of this murky abyss. It's not angry, it's not even particularly hostile. It's just vast, unknowable, confident in its ambiguity. And you, tiny explorer in your imaginary suit, are just here for the view. You spin slowly, eyes scanning for anything familiar. A shape, a color, a ripple, and then you realize there's no ground to land on, ever. If you dropped a probe here, it wouldn't land. It would just continue falling, slower and slower, denser and denser, until it was crushed, melted, or simply became part of the atmosphere. You think about the word surface, how comforting it is, how Earth has spoiled you with mountains and plains and beaches. Neptune offers none of those. Instead, it offers depth without end, layers upon layers that never stop becoming. And that's oddly calming. You reach out one hand, not to touch anything, but to mark your presence, just a silhouette in a planet's memory. You feel the slow rotation of the planet around you, not in a visual way, but in a gravitational one. Neptune is turning even here at its core, just not as fast as the clouds above. The deeper you go, the less you can trust time. The hours stretch, the days warp. Neptune has a 16-hour rotation, give or take. But what does that even mean when there's no ground to stand on? You're not worried. Not really. You're drifting through a fluid world, where the rules are softened and the colors are muted and every molecule is just trying its best under ridiculous pressure. That's relatable, honestly. So you let yourself go slack. Let Neptune carry you further down, past where sunlight ever reaches, into the belly of an ice giant with no ice, into a mantle with no mantelpiece, into layers of matter and mystery so tightly bound, they don't even recognize the terms anymore. This is where Neptune begins, or maybe where it ends. You're still drifting, and by now you've accepted that Neptune isn't going to give you anything concrete. No firm terrain, no conveniently labeled buttons that say core here, no geological brochures. What it does offer, however, is drama. Subtle, slow-burning drama that takes place over weeks, months, even years. And nowhere is that more visible than in its enormous wandering storms. You feel a twitch in the current, a spiral in the mist. Then, out of the gloom, it begins to materialize, a dark vortex curling slowly against the grain of the surrounding winds. At first, it looks like just a smudge, like someone forgot to blend the paint. But as you float closer, the spot deepens, grows, becomes something unmistakable. It's a storm, a really big one. You've met Neptune's infamous great dark spot, or at least one of its seasonal variations. Because unlike Jupiter's angry and persistent red spot, Neptune's storms are a little less committed. They form, they swirl, they drift lazily across the atmosphere, like a traveler with no set itinerary. And then, one day, they vanish. Sometimes without warning, sometimes replaced by a new one eerily similar, in almost the same location. That's part of the charm. The first great dark spot was spotted by Voyager 2 in 1989, a truly moody storm the size of Earth. But when Hubble tried to check up on it a few years later, it was gone. Evaporated. Poof. No forwarding address. Since then, other dark spots have come and gone. They all look similar ovals of darkness, rotating counterclockwise, surrounded by brighter cloud bands, and frequently capped with those crisp white methane scooter clouds that zip around their edges like racing fans on a scenic loop. You hover just above one now. It spins slowly, patiently, like it's posing for a long exposure photo. You can almost imagine it humming to itself a low-board tune only storms understand. Scientists still debate what causes these dark spots to form in the first place. They think they're high-pressure systems, unlike the low-pressure hurricanes we know on Earth. These would be anticyclones, swirling blobs of relatively warm air that descend and push clouds away, exposing deeper, darker layers beneath. The storm's core is quieter than expected. There's turbulence, sure, but it's not violent. The winds here max out around 1,500 miles per hour, but they're smooth, elegant. You feel like you're watching a very large creature sleep. The atmosphere around the storm plays along. The surrounding winds shear past it like water flowing around a boulder. and it just spins unaffected, dragging its own microclimate behind it like a royal cape. Some storms on Neptune develop bright companion clouds. You see one now, a little puff of brilliance riding just ahead of the storm's curve. These clouds are thought to form as atmospheric gases are lifted by the storm's rotation, cooling and condensing into visible ice particles. You drift through the companion cloud, and it's like slipping through a marshmallow laced with frostbite. Brief, cold, beautiful. The particles catch what little sunlight there is and scatter it in all directions. You blink dazed by the subtle rainbow edges that form in the mist. And then suddenly the cloud dissipates, vanishing, like a breath on cold glass. Back in the main vortex, you notice something else. The storm is slowly moving. Not just rotating, but migrating across latitudes. Neptune's dark spots don't stay in one place. They drift toward the equator, slowly degrading as they interact with changing wind currents. Eventually they become unstable. They fragment, they dissolve. It's like the planet has a seasonal memory of storms. They return, but never exactly the same. There's no permanent record, just the idea of a storm recreated with new variables. You float beside the swirling edge and imagine what it would be like to stay here, to orbit the storm endlessly, watching it change shape, color, velocity, watching it fade and maybe be reborn years later under a new name. There's something hypnotic about it. The way Neptune recycles its tempests, the way it never quite repeats itself. Earth has patterns, hurricanes, typhoons, monsoons. But Neptune has moods, long slow moods that last for seasons, and then melt away like forgotten dreams. You let that thought settle into your chest, because even storms here are sleepy. Astrophysicists have noted that the dark spots seem to emerge every few Neptunian years, roughly every 165 Earth years. That makes tracking trends tricky. Our entire digital age hasn't even lived through one Neptune year. We're still toddlers in its timeline. That long memory makes the planet feel wise, in a way, like it's seen more than it says. It watches stars blink in and out. It watches moons pirouette. And it conjures these storms when it feels like it, just to see if we're paying attention. You glance back at the dark spot one last time. It's still spinning, of course, still holding its shape like a very calm but determined pancake. And then, just as softly as you arrived, you begin to drift away. The storm shrinks behind you, curling once, then twice, then disappearing back into the haze. You leave it as you found it, unexplained. As you glide farther along Neptune's upper atmosphere, you start to notice something faint, almost shy, brushing across the edge of your vision. At first, you think it's a trick of the light, a smudge on your visor, or maybe a leftover thread of storm cloud. But no, it's real. It's circular. It's trying not to be noticed. Rings. Yes, Neptune has rings. Don't be embarrassed if you forgot they're easy to miss. In fact, Neptune's rings are so faint and irregular that when Voyager 2 first captured images of them, in 1989, scientists weren't entirely sure what they were looking at. Were they full rings? Arcs? Mysterious smudges on the cosmic windshield? Turns out it's all of the above. You're floating near one of Neptune's more prominent ring arcs now, and it's less like Saturn's magnificent hoops, and more like a glittery accident. The particles here are dark, composed mostly of radiation-darkened material, and possibly tiny fragments of ice and rock. They don't reflect much light, and in the dim glow of far-flung sunlight, they look more like charcoal dust in zero gravity. You drift through the Leverrier ring first, named after the mathematician who predicted Neptune's existence before anyone had seen it. It's a lovely cosmic thank you card, even if the ring itself is modest. You wonder if Leverrier imagined his name floating around the solar system in the form of a dusty, loosely held together ribbon. The particles here are surprisingly varied. Some are microscopic, some chunkier like gravel made of shadow. Unlike Saturn's icy loops, Neptune's rings aren't bright. They don't shimmer or gleam. They barely admit to being here at all. They whisper. They murmur. They float like secrets that didn't want to be kept but weren't loud enough to escape. You pass a bright clump, a denser patch of particles called an arc. These arcs are strange because physics says they shouldn't exist. Over time, gravitational forces from the planet should spread particles evenly around the ring. But Neptune's arcs stay lumpy, clumped, localized, and scientists are still not entirely sure why. One theory. The nearby moon Galatea might be herding the particles through gravitational nudges, like a sheepdog made of rock and ice. Galatea's orbit is just inside the Adams ring, where the most prominent arcs reside: Fraternité, Liberté, Courage, and Égalité. Yes, the arcs have very French names, très chic. You pass through Fraternité now. It's thicker than the others, its particles gently swarming like bees made of obsidian. You slow down to feel the motion, if feel is even the right word. It's more like sensing texture without touching it, like watching snowfall through tinted glass. And then there's the weird part: these rings are unstable. They're temporary, they shift. Some may vanish completely over the next few decades, or centuries, or maybe just Tuesday. We don't know. Neptune's rings are impermanent structures, cosmic mayflies flitting around a sleeping giant. That impermanence makes them beautiful. Most people, when they think of planetary rings, think of Saturn's flamboyant fashion statement. But Neptune wears its rings like old jewelry. Subtle, dusty, sentimental. You almost miss them, and now you don't want to leave. You tilt your trajectory and glide outward slightly, catching a side view of the entire ring system. It's not a full circle, not really. It's patchy like a broken bracelet. But there's something deeply satisfying about its messiness. You imagine Neptune wearing it not for show, but for comfort. Like a scarf you only wear inside because it smells like someone you used to know. Voyager 2 spotted at least 5 main rings: Gale, Leverrier, Lassell, Arago, and Adams. They're thin, not paper thin, thread thin. You could fly through them and never notice unless you were looking directly into their dim reflections. You do now. You take a moment. You stare straight into the ring plane. Tiny particles blink as sunlight skims their edges. Some seem to tumble, others float with impossible stillness. One larger piece spins slowly, silently. You imagine it's a piece of a moon shattered long ago by some forgotten collision. That's one theory about how the rings formed moon fragments scattered into orbit after violent impacts. Or maybe they're leftovers from Neptune's birth scraps of creation that didn't get swept up in the final planetary construction. Either way, they're survivors. And they've been through a lot. Solar radiation, micrometeorite bombardment, tidal forces, time, so much time. You try to calculate how long a ring particle might last, but Neptune's math is fuzzy. Too far, too unstable, too vague. The particles could spiral inward, eventually burning up in the upper atmosphere, or drift outward and escape entirely, or crash into Galatea, which is frankly just trying to mind its own business. Still, they orbit, for now. And you, for now, are part of that motion. You trace a wide loop along the ring arc, matching its path for a while. It feels like riding shotgun in a very slow, very faint roller coaster. No screams, no rails, just dust and gravity, and the occasional poetic name, whispered through the void. You know these rings won't be here forever, but for tonight they are. You're starting to get the feeling Neptune doesn't like to do anything the usual way. Its winds break the rules, its rings whisper instead of shout, and now, just to really make a point, it's time to talk about Triton. You tilt your angle and drift outward away from the ring plane, following the path of one of Neptune's many moons. But this one's different. This one's special. This one is going backwards. Triton, Neptune's largest moon and one of the strangest in the solar system. You float beside it now, watching as it orbits in the opposite direction of Neptune's rotation. A retrograde orbit, which is science speak for this moon, is doing donuts in the wrong lane. And it's not even subtle about it. Most large moons orbit their planets in the same direction the planet spins. It's the natural order of things. But Triton, nah. Triton does a slow, silent pirouette in the other direction, like it joined the dance floor late and refused to follow the choreography. You look closer. Triton is cold. Really cold. Colder than Neptune even. Its surface is an icy crust of nitrogen, methane, and carbon monoxide, frozen gases that give it a smooth, reflective sheen. You see hints of pink and lavender on its surface, like it's blushing in the starlight. And despite all that quiet beauty, this moon has been through some things. The prevailing theory is that Triton wasn't always Neptune's. It used to be a Kuiper Belt object, a wayward traveler from the outer solar system, possibly a dwarf planet in its own right. But at some point, Neptune caught it. Not like a hug, more like a surprise tackle. Gravitational interactions yanked Triton into orbit, stealing it from the outer darkness and locking it into a backward swirl. The capture was probably violent, the kind of cosmic event where orbits get wrecked and smaller moons get yeeted into deep space. Some may have crashed into Neptune, others flung away never to return. Triton remained, but not without scars. Its orbit is tilted, odd, eccentric, and slowly, tragically, it's spiraling inward. One day, Triton may fall into Neptune entirely, or be torn apart into a new set of rings. But don't worry, it's not scheduled for another few billion years. You have time. For now, you coast along Triton's edge. Its terrain is a masterpiece of frozen geology. You see cantaloupe terrain. Yes, that's the real term, covered in wrinkles and ridges that look like the surface of an alien fruit. There are smooth plains, jagged cliffs, and geysers. Real ones. Triton has cryovolcanoes, ice volcanoes that erupt liquid nitrogen into space, which then falls back as gentle frost. You imagine it snowing nitrogen here, whisper quiet, glittery, a snow globe with zero visibility and temperatures near 235 degrees. You hover over one of these geyser fields. Voyager 2 spotted them in action, spurting plumes several kilometers high. That was in 1989, and we haven't been back since. Still, the evidence remains dark streaks on the surface, where frozen particles fell back and painted the ice in delicate brushstrokes. Triton is geologically active despite the cold. Some think its interior is warmed by tidal flexing its strange orbit, creating friction inside that keeps parts of it from freezing solid. Others think the core still has leftover heat from formation, or maybe radioactive decay, ticking away quietly like an old space heater. The moon is locked in synchronous rotation, meaning the same side always faces Neptune. You orbit around to the far side and everything feels a little lonelier, a little less watched. You wonder what it's like to be a moon forever showing only one face, like a poker player who only ever reveals the same card. From here, you can see Neptune in the distance, a massive blue sphere turning slowly indifferent as ever. You realize that Triton, for all its backward rebellion, is now part of Neptune's story, a captured outsider, a reluctant ally. You drift downward, skimming the icy surface. It's smooth in some places, chaotic in others. You spot impact craters that seem half-filled as if the moon is trying to erase its history. There are trenches that stretch for hundreds of kilometers, formed by internal shifts that would terrify any planetary geologist with a bedtime schedule. And still, there's silence. No wind, no waves, just frost shadow and the gentle tug of Neptune in the sky. You wonder what Triton thinks about all this, if it remembers where it came from, if it misses the cold emptiness of the Kuiper Belt, or has grown used to Neptune's company. Maybe it doesn't think at all. Maybe that's your job. You hover for a moment longer. Let the quiet settle. Let the icy light wrap around you like a soft blanket pulled from a distant freezer. You give Triton a nod, a thank you for the show, and as you drift back toward Neptune, you glance over your shoulder and watch the moon shrink behind you. Still spinning the wrong way, still doing its own thing, like all the best rebels do. The space between Neptune and Triton stretches behind you like a soft exhale. You feel it thinning the grip of the moon's backward ballet, loosening its fingers. Ahead, Neptune swells again in your view, silent and endless. You dive gently back into its atmospheric veil, skimming the edge of clouds that seem to rearrange themselves just for you. Now it's time to visit one of Neptune's strangest traits. Not the color, not the storms, not the rebel moon, but something subtler. Something that on any other planet would make perfect sense. Heat. Specifically where it goes, how it moves, and why. On Neptune, it seems to do the opposite of what you'd expect. You glide downward, letting the pressure increase once more, watching light fold in on itself. The atmosphere thickens like honey that's forgotten how to flow. And here's where it gets weird. You're entering a layer where warmth, instead of rising, starts to sink. Let's pause. On Earth, you're used to a straightforward deal. Warm air rises, cold air sinks. This principle is responsible for everything from weather patterns to how your upstairs bedroom becomes a sauna in summer. But on Neptune is not a fan of this rule. Models suggest that in certain parts of the planet's atmosphere, the opposite might happen. Hot air, instead of floating cheerfully upward, actually dives. It sinks into cooler layers beneath, reversing the expected flow. It's like someone rewired the convection system just to see what would happen. You're now drifting through one of those suspected zones. There's no sign to mark it, no red arrow saying heat sinks here. But you feel the pressure increasing and the temperature doing something unexpected, flattening, stalling, curling back on itself. Astrophysicists still debate whether this really happens, or if it's a misinterpretation of incomplete data. After all, most of what we know about Neptune comes from a single flyby and some clever telescope work. It's like trying to solve a jigsaw puzzle when most of the pieces are hidden behind clouds 4.5 billion kilometers away. Some think the sinking heat is caused by layers of radiative cooling, where the energy that should rise upward instead gets trapped by molecular interactions in the atmosphere. Others think there may be compositional gradients, meaning different kinds of gases and ices forming subtle chemical boundaries that prevent convection from working the way it usually does. It could even be that Neptune's internal heat, the energy it radiates from its core, is so oddly distributed that it causes downward flows in some places. Neptune emits more than twice the energy it receives from the sun, but that energy doesn't spread evenly. It creates mismatched motions, unexpected flows, and, well, here we are, floating in reverse. You look around. There's no chaos here, no turbulence, Just an eerie stillness, like the air is moving in slow motion, rearranging itself in quiet defiance of logic. It's peaceful in a way. You imagine the heat, curling like a sleepy cat, finding its way downward, tucking itself in, not rushing, not roaring, just shifting under its own gentle weight. Some models even suggest that this upside-down convection could influence Neptune's strange weather. Maybe it contributes to the planet's rapid winds by creating a subtle tug-of-war between layers. Maybe it helps power the temporary storms you saw earlier. Or maybe it's Neptune's way of slowing things down in a place where everything else moves too fast. You think about that for a moment. A planet where the wind screams, but the heat sinks softly quietly. A paradox wrapped in blue fog and superfluid elegance. You pass through a pocket of methane haze, watching the particles dance in soft spirals. They aren't rising or falling quickly, just hovering suspended, caught between up and down. It's like the planet itself isn't sure which direction it wants to go. You spot a shimmer in the distance, another high-altitude cloud, streaking white against the muted cobalt. It's caught in a band of eastward wind moving faster than anything should out here. And yet beneath it all, you know the deeper heat is drifting the other way. This image sticks with you, motion on top of motion-layered systems, doing contradictory things like a symphony, where each section plays a different melody. Somehow, it still works. Somehow, Neptune doesn't fly apart. Instead, it hums. You picture the inner heat, escaping slowly, patiently, like a sigh held in for centuries. It doesn't rush. It doesn't burn. It drifts sometimes downward, sometimes not at all. You glide through another pressure layer, feeling the drag change slightly. The colors shift again, more muted, now a gradient between graphite and cerulean. You think of the deep ocean on Earth. You think of whales. Then you remember, Neptune has no whales, no seafloor. Just this vast slow movement of gases, pretending to be oceans. Still the comparison fits. There's something distinctly marine about this place, not just because Neptune's named after a sea god, but because of how it behaves, fluid, secretive, and surprisingly moody. And then it hits you again. That strange comfort, the knowledge that this planet doesn't have to explain itself, that even its heat, its most basic energy can choose its own direction, and no one can stop it. You're surrounded now by air that's heavier than it should be, moving slower than you'd expect, and warmer than logic says it ought to be at this depth. And it all feels right. The longer you stay, the less important normal feels. You begin to let go of assumptions. Maybe heat doesn't always rise. Maybe storms don't have to stay. Maybe moons can orbit backward, and rings can fall apart, and it's all fine anyway. You close your eyes for a moment, just metaphorically, since you're still technically watching everything unfold. The planet breathes, the warmth descends, and you drift right alongside it. You rise again, lazily curling upward, through Neptune's layered haze, as if carried by one of the planet's occasional whims. After spending so much time pondering sinking heat and swirling ice mist, it's almost refreshing to climb slowly, steadily into one of Neptune's weirdest and most offbeat features, its magnetic field. Now, every planet with a core worth its salt has some sort of magnetic field. Earth's is tidy, aligned closely with its spin axis. Jupiter's is a thunderous beast of electromagnetic discipline. Even Uranus, tilted dramatically, seems to have at least agreed on where its field begins and ends. But Neptune's magnetic field is the cosmic equivalent of forgetting which way your desk chair faces. It's tilted at a bonkers 47 degrees relative to the planet's rotational axis. That's like trying to spin a top and having the invisible field around it point somewhere between your foot and the microwave. You pass through the first wave of it, now an invisible veil of magnetism, gently curling through space like radio static made into sculpture. You can't see it, but you feel the shift. Something subtle changes in your imaginary instruments. A faint warble, a cosmic wobble, the sensation that your compass just rolled its eyes and said good luck. Neptune's magnetic field also isn't centered in the planet. It's offset, lopsided, like someone put the magnetic core in slightly the wrong place and decided to just roll with it. The result is a field that twists and tumbles as Neptune spins. Not in a lazy circle, but in a lurching, off-balance kind of way. It's less a spinning top and more a toddler learning to dance. You float within it, now riding the edge of its influence. Charged particles stream by protons and electrons, spiraling along magnetic lines caught in a celestial mosh pit. Occasionally you get a tiny pop of brightness. Neptunian aurorae, faint and patchy, flickering near the poles. Not the grand light shows of Earth or Saturn, but smaller, glitchier. Neptune's way of saying, I do auroras, just differently. Astrophysicists have tried to model this oddball magnetic field for decades, and honestly, they're still squinting. The current best guess is that it originates not in a metallic core, like Earth's, but in the conductive layer of salty superpressurized fluid near the mantle, possibly a slurry of ionized water and ammonia, basically very angry Gatorade. That fluid, swirling and convecting, could be generating this tilted offset magnetic dance floor. But again, Neptune's not confirming anything. It just spins its strange field and lets us wonder. As you drift deeper into the magnetosphere, you feel the occasional pulse. Not painful, not sharp, just rhythmic, like a soft electric heartbeat, thudding beneath the atmosphere. There are zones within Neptune's field where radiation builds up trapped belts, not unlike the Van Allen belts around Earth. These regions are less intense than Jupiter's brutal radiation zones, but still potent. A probe flying through them would need shielding. You, however, are imaginary and therefore gloriously immune. You imagine Voyager 2 cruising through this space decades ago, its instruments picking up wobbles and pings, data that took hours to beam back to Earth. The spacecraft didn't linger long, it had places to be other planets to charm. But in those brief moments, it glimpsed Neptune's invisible personality, caught whispers of its electromagnetic secrets. And then it moved on. You pause here, letting yourself gently spin within a magnetic loop. It's oddly relaxing, like swinging in a playground with no ground in sight. You trace the arc of the field, watching particles dance their endless orbits. Each one is a traveler or wanderer, caught between motion and force, forever bound to the geometry of Neptune's inner confusion. The magnetic axis and the rotation axis are so mismatched that the field visibly wobbles as the planet spins. If you could paint it with light, it would look like a giant lopsided jellyfish, made of auroras and static, which frankly you'd pay to see. This misalignment isn't just aesthetic, it affects how solar wind interacts with the planet. Neptune's magnetosphere gets squished on the sun-facing side and stretches dramatically into a long tail on the far side like a comet made of invisible tension. You follow that tail for a moment, drifting backward through its ghostly length. It hums faintly like a violin string stretched too far. Somewhere far down the line, the field merges into the interplanetary magnetic current, the great shared ocean of charged particles drifting from the sun to everywhere else. But Neptune's contribution to that ocean is uniquely shaped, warped, tilted, a silent, drifting question mark. You loop back toward the planet now, curving through the northern magnetic pole, which in a final act of defiance doesn't line up with the geographic one. It's off-center, slightly sunken, like a misplaced sticker on a snow globe. You pass through another flicker of aurora, and for a moment you feel the weight of distance. The sun is so far away now, over 30 times farther than it is from Earth. And yet the solar wind still finds Neptune, still teases its magnetic field, still makes it glow. You let that linger. The idea that even out here in the quiet edge of our planetary neighborhood, there is motion-energy exchange. Neptune may seem cold, indifferent, but its magnetosphere hums with motion. And so do you. You turn your gaze outward now, away from Neptune's spinning field lines and chaotic atmospheric whispers. The sky clears just enough to open a small porthole in the clouds, a glimpse of darkness beyond. And through that deep velvet silence you spot something familiar, a tiny silver arc slipping across the black. It's Voyager 2, or rather it was. You float in memory now back to 1989, when humanity's most loyal interplanetary tourist took its one and only glance at this distant moody planet. Voyager 2 didn't orbit Neptune, didn't linger, didn't even stay for dinner. It just swooped by, took a handful of photos, scribbled some notes in its digital journal, and coasted into the void, like a polite guest who didn't want to overstay its welcome. Still, what it gave us, those brief hours of proximity, formed the foundation of everything we know about Neptune today. You drift closer to where the flyby happened, pretending for a moment that you're Voyager's shadow. You imagine the craft zipping past cameras, snapping, its instruments clicking, whirring measuring fields, scanning clouds, recording emissions. A slow ballet of science wrapped in metal and curiosity. Voyager 2 was already 12 years into its journey when it reached Neptune. It had visited Jupiter, Saturn, and Uranus. Neptune was its final planetary encounter, after that interstellar space. But before disappearing into the cosmic suburbs, it paused here long enough to gift us one final set of planetary postcards. You hover now in the path it took, watching the route unfold. This was the first time humans had ever seen Neptune up close. Before Voyager, it was just a blue dot on photographic plates, a math-confirmed mystery, but the flyby changed that. It revealed storms, clouds, a magnetic field that scoffed at geometry. It found the rings barely and confirmed their arc-like weirdness. It even spotted 6 new moons hiding in the darkness, like backstage extras waiting for their cue. But the crown jewel of that visit, Triton. Voyager 2 gave us our first and only detailed images of Neptune's largest moon. The geysers, the cantaloupe terrain, the frozen nitrogen crust. Without those grainy, beautiful pictures, Triton would still be a mystery too far to dream about. You imagine the engineers back on Earth watching data stream in pixel by pixel. No instant download, no live stream. Just silence, then a beep, then a line of numbers. A planet slowly unfolding across black and green screens. Voyager's closest approach was just under 5,000 kilometers from Neptune's cloud tops, closer than it got to any other giant. At that distance, the planet filled the camera frame, looming like a storm held in suspension. You picture it, the wide crescent of Neptune, lit by distant sunlight, the shadows curving over the methane clouds, the faint arcs of the rings barely visible against the stars. A fleeting glimpse of a planet too distant for return visits. And then Voyager was gone. You drift now in that same outbound path, watching Neptune shrink behind you. It's like watching a dream close its eyelids, quiet, final. Voyager 2 would never see another planet again, but its memory of Neptune would shape decades of science. You follow its trail for a while, letting yourself coast through imaginary wake turbulence. The silence here is thick post-mission stillness. But it's also proud. Voyager left behind questions. Not because it failed, but because Neptune refuses to be explained in one sitting. We still rely on that single flyby. Most of what we know about Neptune, the wind, speeds the rings. The odd tilt of its magnetic field comes from that narrow window in August of 1989. 36 years ago. A planetary blink. You pass through a faint trail of charged particles, remnants of the magnetosphere still spinning, still processing Voyager's brief presence. Somewhere out here, Neptune still remembers, still hums with the echo of that visit. It's strange how little we followed up. No orbiters, no probes, no landers, because, well, there's nowhere to land. Just long-range telescope work from Earth Hubble, and recently the James Webb Space Telescope. But even those can only do so much. It's like Neptune asked us a question in 1989 and we haven't replied. Yet, plans exist, of course, proposals for Orbitus missions to study the ice giants in more detail, but they remain on drawing boards waiting for funding for launch windows for patience. It takes years to plan a trip to Neptune, and decades to arrive. But Voyager didn't wait. It went, it saw. And in that single elegant arc, it taught us that even the coldest, farthest planet is alive with motion. You imagine it now still moving, still outbound. Voyager 2 is over 130 astronomical units from Earth, as of tonight, sailing beyond the reach of the sun's influence. But it carries that memory. It holds Neptune's whisper in its circuits. And you're here now, filling in the silence between transmissions. One visitor, one flyby, one planet still spinning. You let that linger in your chest, light and quiet. The stars above you blink once, and Neptune turns softly below. You coast downward again away from Voyager's ghost trail, letting the memory of its flyby dissolve into Neptune's deepening hues. The atmosphere thickens, the colors compress, and beneath that pressure, somewhere in Neptune's vast concealed middle, you begin to imagine something improbable, something luxurious, something glittering, diamond rain. It sounds like science fiction, or maybe a perfume ad. But here on Neptune, it's more than a pretty phrase. It's one of the most poetic predictions in planetary science. Beneath the outer layers of methane and hydrogen, deep in the crushing belly of the planet, carbon atoms may be squeezed so hard they form crystals, real diamonds falling slowly through the darkness. You descend toward the theoretical. There's no diamond zone labeled in Neptune's layers, no sparkle to guide your way. But based on what we know about Neptune's chemistry and what we've recreated in Earth-based labs, scientists believe that the intense pressure and temperature in the planet's mid-mantle could force carbon atoms to rearrange themselves into solid diamond structures. And here's the part that sticks with you. They don't explode into being. They don't shoot through the atmosphere like glittery bullets. They fall, quietly, slowly, gently. Imagine raindrops the size of pebbles made of crystal, drifting through a fluid layer of methane, ammonia, and water ice, glinting in the dark, sinking through thousands of kilometers like elegant wreckage. You pass through a layer of pressure so dense it makes steel feel soft. The temperature is rising, but not enough to melt the diamonds, at least not yet. The theory is that the carbon begins as methane molecules, CH4, which under high pressure break apart. The hydrogen gets squeezed out, and the carbon atoms, free at last, begin to form chains, sheets, then crystals. And down they fall, Not rain in the way Earth knows it, not cold drops tapping windows. Neptune's diamond rain is slow and solemn. It could take thousands of years for a single crystal to reach the core. By the time it gets there, it might melt into the strange, metallic soup believed to exist at the planet's deepest point, or it might collect, accumulate, pile into a layer of glittering sediment, a crust of diamonds, under unimaginable pressure. You drift lower, letting the idea settle. Somewhere down there, invisible to any telescope, there could be a layer of solid diamond, a buried continent of crystallized carbon pressed smooth by planetary gravity. Not treasure, not jewelry, just geology. Just Neptune doing Neptune things. And it's not just Neptune. Uranus likely has diamond rain too. Maybe Saturn, possibly even Jupiter. But Neptune. It's the best candidate. Its size composition and internal pressure make it a 5-star diamond rain resort. You start to picture the sound. Would it make one? Would these falling crystals clink together like wind chimes or move in complete silence like underwater snow? You'll never know. The pressure here would crush any probe long before it heard anything. And besides, in Neptune's layered soup of hydrogen and helium, sound travels differently. Slower. Weirder. It's not a place for microphones. Still the image persists, diamonds falling, slowly, eternally. You think about Earth, about how we treasure diamonds, cut them, polish them, lock them in tiny boxes. We call them rare, precious. But here, on Neptune, they're weather, just part of the cycle. Atmospheric jewelry on a planetary scale. And Neptune doesn't care what they're worth. You imagine one such crystal falling past you, now a shard of refracted light, shaped by gravity and heat. It rotates slowly, untouched by hands or commerce, just tumbling through the layers the way a leaf falls through still water. You don't try to catch it. You wouldn't be able to. It's moving slow, but it's heavy, dense, and besides, it's not for you. It belongs here. It's part of the planet's rhythm. You turn slowly, letting your field of vision widen. There's no sparkle, no glitter, but the idea alone fills the space around you like soft music. It's not about seeing it. It's about knowing it might be there. Diamond rain. Not flashy, not rare, just Neptune's quiet luxury. And somewhere down below, in the place where temperature and pressure meet those diamonds, might even melt, form a metallic carbon ocean. A literal sea of liquid diamond. The thought makes your spine buzz. Liquid carbon flowing under crushing weight. Not something you'll ever see. Not something we'll ever reach, but beautiful in a distant, impossible way. Scientists are still testing these ideas, recreating Neptune's pressure in labs using lasers and diamonds of their own. They've seen carbon turn crystalline under the right conditions. They've watched it form tiny flecks like stardust. They've nudged the mystery a little closer to certainty. But Neptune doesn't confirm. It doesn't reply. It just keeps making diamonds in the dark, then quietly erasing them with time. You rise a little now back toward the less intense layers. The pressure drops, the temperature cools, but you feel a new weight in your mind, the comfort of knowing that somewhere down there diamonds are falling softly, endlessly unnoticed. Because not all brilliance has to be seen. You rise from the glittery depths, the notion of diamond rain still trailing behind you like perfume in the airlock. The higher you drift, the more Neptune reverts to its fluid norms, lighter winds, methane haze, and those haunting wind-polished blues. Now let's talk about time. On Earth, time is something you carry in your pocket. Something that nags you about meetings and meals and when to water your houseplants. But here on Neptune, time is inconsistent, slippery, politely uncooperative. You float near the equatorial band, now riding a current that feels half wind, half attitude. The planet is still spinning, but you're starting to realize that a day on Neptune depends entirely on where you ask. At first glance, Neptune's rotation seems straightforward, about 16 hours for a full turn. One fast storm-tossed day on a planet 17 times the mass of Earth. But when scientists tried to lock that number down, they got different results. Different answers from different altitudes. The clouds say one thing, the magnetic field says another. And the interior, well, it's not really speaking to anyone. You try asking the clouds. They zoom around at ludicrous speeds, up to 1/200 millipieces at mid-latitudes. By watching cloud movements, researchers estimate rotation at around 18 hours in some places, 16 in others. But those clouds are just decorative frosting. They might not reflect the core's actual spin. Then there's the magnetic field. It wobbles like a dizzy metronome, but it gives a better clue to what's happening inside. Based on magnetic readings, Neptune's deep interior may spin closer to 16.11 hours. So, is that the real Neptune day? Not exactly. Because gas giants don't have solid surfaces, defining rotation becomes an awkward group project with too many opinions. There's no single chunk you can put a stopwatch on. The atmosphere moves at one pace, the fluid interior at another. Some regions might be faster, others slower. It's like trying to time a jellyfish dancing in a whirlpool. The phenomenon has a name, differential rotation, a concept that makes Earthlings feel a bit seasick. Jupiter does it, Saturn does it. But Neptune, in its typically vague fashion, does it less consistently. Its differential rotation varies with latitude and depth, and even seasoned astrophysicists raise an eyebrow at the data. You loop along a higher latitude current now. The winds shift direction. At the equator, they rushed westward. Here they tug eastward like Neptune is trying to tie itself in knots. The result: a complex planetary rhythm, like jazz, without sheet music. You glance down, there's no solid ground to use as a reference point, no helpful landmark to say, this is where we started. You're stuck counting swirls, timing, magnetic flickers, and trusting that maybe Neptune is keeping time in a language we don't understand. And really, does it matter? You float through this shifting clockwork, watching shadows form and dissolve on cloud bands. The sunlight here is barely a suggestion too faint to cast a proper shadow too weak to enforce any schedule. A day on Neptune may be 16-ish hours long, but how does that feel? There's no sunrise, no sunset. Just a slow dimming, a gentle change in hue. Light doesn't pierce the atmosphere so much as it is politely filtered, diffused through methane and memory. You think of Neptune's moons now, especially the tiny ones, Nesupsamati Laomedea. They orbit so far out they barely count. They take years to complete a single loop. Their days stretch long, silent, uncaring. Compared to them, Neptune's spin is a blur. Still, you try to imagine living here. What would a clock even look like? Would you follow the rotation of the magnetic field? The cloud tops? Would your hours match the winds or the internal pulses? Or would time just dissolve, become meaningless against the vast hush of this place? You drift through a patch of atmosphere so still it feels paused. You blink slowly. Nothing changes. Maybe a second passed, maybe a minute. You don't know anymore. This is Neptune's time signature, blurred, layered, full of contradiction. Some scientists have even wondered if the planet's irregular heat distribution could subtly shift its rotation over time. Not fast, not obviously, but enough to make old measurements age badly. Imagine a planet that slowly forgets its own schedule. It fits somehow. Neptune is a world of moods, not minutes. It cares more about movement than measurement. You try asking the wind, what time is it? It doesn't answer. You try asking the pressure, how long is your day? It shrugs. You let go of the question, float above the confusion, and feel your own rhythm begin to slow. Because on Neptune time doesn't tick. It drifts. You've now been with Neptune long enough that nothing it does surprises you anymore. Time is ambiguous. Winds are contradictory. Diamonds fall like lullabies. And yet there's one lingering enigma you can't quite let go of. Why are Neptune's winds so strong? No, seriously. Neptune receives barely any sunlight. Only 1/900th of what Earth gets. Its distance from the sun is so vast that the solar energy arriving here is practically a rumor. It should be cold, still, and quiet. A place for gentle breeze, maybe a delicate gust every few years. And yet, the winds on Neptune are the fastest in the solar system. You swirl gently into one of those high-speed bands again, watching methane clouds race past like runners in a foggy marathon. You feel no pressure, no force. But the velocity is real, 1/500 to 2 to 100 kilometers per hour in some regions. That's faster than sound on Earth. That's fast enough to make Saturn's storms look like a lazy Sunday drive. It's like Neptune is overcompensating for being so far from the party. Oh, you think I'm cold and boring? Watch this, it whispers, and then it rips the atmosphere into ribbons. So the big question, where is all this energy coming from? One obvious candidate is internal heat. Like Jupiter and Saturn, Neptune radiates more energy than it receives. It has an internal engine, a slowly cooling core, still leaking heat from its formation 4.5 billion years ago. That heat rises, drives convection, and powers weather. Except, here's the catch, Uranus also has internal heat, and it's practically comatose. Its winds are sluggish, its storms are few. Neptune, on the other hand, throws atmospheric tantrums like a diva in a telenovela. And so scientists debate. Some think Neptune's heat is distributed more efficiently than Uranus's. Maybe it escapes in localized bursts thermal jets that feed into the atmosphere and create intense motion. Others point to compositional differences. Maybe Neptune's interior churns differently, less stratified, more mixed, more energetic at depth. You coast lower, imagining convection cells, swirling in invisible patterns, hot gases, rising from the mantle, dragging atmospheric layers into motion. The clouds you see might just be the froth atop an ocean of turbulence. But it's not just about heat. There's structure at play here too. Neptune's lack of a solid surface means winds don't encounter friction. They don't slow down the way they would on a rocky planet. Instead, they build, sustain, repeat, like a treadmill with no off switch. Add to that Neptune's rotation rapid enough to create strong Coriolis forces, which twist and steer those winds into jet streams. Unlike Earth's 3 or 4 major bands, Neptune has many stacked like lasagna, each moving at its own pace. These bands shear against each other, generating eddies and storms. And you pass through one, now a sideways ribbon of air, spiraling off the main flow, forming a small vortex. It's not violent, just persistent, Neptune's version of a fidget spin. But the real puzzle isn't how the winds stay fast, it's why they get fast in the first place. Solar heating is weak, internal heat is real, but unexceptional compared to Jupiter. And yet, here you are watching clouds whip around the planet with tireless glee. Some researchers propose a self-reinforcing system. Once fast winds form, they generate patterns that protect and sustain them. Vortices trap heat. Jet streams reduce turbulence. Feedback loops form. The more the winds move, the more stable their pathways become. In other words, Neptune's weather might be a self-feeding engine, like a song that loops because it refuses to end. There's another theory still debated, that Neptune's atmosphere contains unknown materials, exotic ices, or trace gases that alter heat transport. If true, these hidden ingredients might unlock a new kind of thermal behavior. But without more data, it's just educated speculation. You pause, letting the wind carry you sideways across the cloud bands. It's strange to think that we've never truly seen Neptune's atmosphere up close. Voyager 2 skimmed it for hours. Telescopes catch snapshots, but there's no orbiter, no weather balloons, no hurricane chases in tiny space raincoats. So we build computer models, plug in equations, tweak them, until they look like the pictures. And then we say maybe, which on Neptune is the closest we get to yes. You circle around the South Pole, where the winds converge in strange swirling bands. Some models suggest a polar vortex, here spinning like a drain, with too many settings. But it's all theory. Everything is theory. Neptune has given us just enough data to be curious and just little enough to remain mysterious. You dip into a mid-latitude jet, watching the layers speed past, and you realize something: the winds aren't in a hurry. They're just committed. They're not racing, they're rehearsing. Over and over, for centuries. The speed feels peaceful now. Not frantic, not aggressive, just continuous motion in a place that refuses to sit still. You stretch out your hand, let the invisible force brush your fingers. You can't feel it, not really, but you imagine what it would be like. A gale that never bites. A storm that never screams. And above it all, Neptune spins. Not fast enough to cause this. Not slow enough to prevent it. Just enough. You realize now that the real answer may be this. Neptune is a balancing act. A planet where subtle forces add up to spectacular outcomes, where mild heat, weak sunlight, and atmospheric freedom create the wildest winds in the solar system. You smile, because the math still doesn't quite work. And Neptune doesn't care. You've been riding Neptune's mysterious currents for quite a while now. Winds that race faster than anything on Earth. An atmosphere thick with methane's blue glow. Storms that appear and vanish like cosmic daydreams. And moons that dance backwards in defiance of expectation. You feel as if you've lived a lifetime inside this distant giant's embrace. And yet, for all that you've learned and seen, Neptune still holds secrets. Quiet ones. Secrets wrapped in the cold, still folds of its atmosphere, and tucked deep in its unknown interior. You drift gently, now letting the last wisps of clouds pass around you, like old friends bidding farewell. Some of the mysteries about Neptune remain locked away, its exact internal structure, the true mechanism, powering its furious winds, the details of its magnetic field, even the full story of its rings and moons. Scientists continue to debate and speculate using the sparse data we have combined with telescopic observations, complex computer models, and lab experiments that simulate the crushing pressures and icy temperatures. But Neptune has never been fully explored. Its complexity resists easy answers, and maybe that's exactly how it wants it. There's a peacefulness in that, in the not knowing, in the space for wonder. You realize that Neptune doesn't just spin silently in the darkness. It invites you to spin along, to ponder, to marvel. Its contradictions, the slow rotation and the furious winds, The faint rings and the powerful storms, the cold exterior and warm interior are like a lullaby, sung in paradox. They lull you into a contemplative calm, where questions are more important than conclusions. As you float, the blue around you deepens. The methane clouds grow soft and fuzzy like cotton candy, dissolving in warm tea. The winds slow, the pressure eases, and the edges of your consciousness begin to blur. Neptune's distant sun casts a faint tender light, no longer harsh or urgent, but like the glow of a bedside lamp left on for the night. The planet's atmosphere cradles you gently, a vast and infinite comforter. You are drifting now, not just through space, but through thought and feeling. The mysteries of Neptune become whispers, and you welcome the quiet. Slow your breathing. Let the tension slip from your limbs. You're safe here, in the vast cool blue. And as the last faint streaks of wind wrap around you, the gentle hum of the universe fades into a soft silence. Thank you for joining this journey through Neptune's serene contradictions. May your dreams be as deep and wondrous as the distant ice giant itself.